Okay, welcome to part 3 of my Trig Identities series. This is the final part that I'm going to do. In this video I'm going to do 3 trig verifications that are a little bit more complicated than the first 6 that I did in the previous 2 videos. So if you haven't watched those 2 yet, I would definitely do that first. I might even start with the video that is entitled Deriving the Pythagorean Identities, just to get a refresher about where those things come from in relation to the unit circle and stuff. What I'm also not going to do in this video is talk about the guidelines for verifying trig identities. I'm just going to get right into it because these 3 are going to take quite a bit of time. But what I'm going to do here is, again, just to refresh your memory, I'm trying to get this left-hand side to be exactly the same as the right-hand side, right? And the number 1 rule is look at the more complicated side and try to change that first. This is definitely not the more complicated side, so I'm going to leave that alone. I'm going to leave 2 secant x over there, and I'm going to try to get the entire left-hand side to be that. Right? Now, this is not an equation right now because we're trying to verify if it's true. So we can't just go subtracting things from both sides and all that stuff. We have to actually stick to one side and mathematically transform it to be exactly what you see over here. If we can do that, then we know that the equal sign is verified. So, where do we start? We start with a little bit of algebra. I see 2 fractions that do not have the same denominators. So what I'll do is I'll get the denominators to be the same. So my denominator is going to be cosine x 1 minus sine of x. Right, if I'm looking for common denominators, the easiest way to do that is to just take this, and then just multiply them together. When I do that, I need to change the top terms as well. So this over here is going to be multiplied by this, and cosine times cosine. So here we go. Let's see. We've got 1 minus sine x times itself plus cosine x times cosine x. Alright, so we've got some common denominators there, a little bit of algebra. Okay, so let's multiply these 2 binomials together with a little bit of distributive property, a little FOIL. First times first, outside, inside, and last. And then these multiply together, of course, to be cosine squared x. And remember, that's all over cosine x times the quantity 1 minus sine of x. Now, notice I'm not going to distribute these 2 together, because a lot of times you're looking for a cancellation on either one of these. So we'll see if we can get that. Let's clean this top up, this numerator 1 minus. We have 2 of these things, so 1 minus 2 sine of x plus, oh wait a minute, this is kind of cool. This is, isn't that 1? Right, that's our Pythagorean identity. Sine squared plus cosine squared equals 1. So I'll change that right now. So I did 2 things right there. Let me move this over a little bit so we can stay organized. Okay, so let's continue to simplify that numerator. 1 plus 1 is 2. So I have 2 minus 2 sine of x divided by cosine of x, quantity 1 minus sine of x. Okay. Any factorizations? Let's see if I can factor out a common term from the top. Yeah, they both have 2 in it, so let's take a 2 out. If I take a 2 out, I get 1 minus sine of x. Denominator hasn't changed in a while, so I'll just keep writing it. Okay, so I see a nice cancellation here. These can cancel, the whole term, this whole term, and this whole term can cancel. So I get 2 over cosine x is equal to 2 secant x. Okay, so that's 2 times 1 over cosine x is equal to 2 secant x. Well, this is, of course, secant x, so I'm done. 2 secant x equals 2 secant x. Now, if that didn't take you as many steps, let's count my steps here. I've got, let's see, 1, 2, 3, 4, 5, 6, 7. If that didn't take you 8 steps, no big deal, right? Maybe you did it in 5 or 6, or maybe you did it in 10. That's okay. As long as you get the right answer and all your math is correct, it's fine. Ideally, you want to do these in the most efficient way as possible, but if you can't, that's okay. Next up. All right, now this one's pretty crazy. I chose this one on purpose. I gave this on one of my recent tests in class. And the trick here is that we actually have to change both sides a little bit. It's pretty rare that you have to do that, but sometimes you do. So here we're going to change both sides. At least that's how I did it. Maybe you can do it a little differently and only change one side. But let's start with the left-hand side, and we'll change that. Actually, I'll just write that again. I'm going to start with the right-hand side. I think it's a little bit easier. So on the right-hand side, I have 1 minus cosine theta. I can't do anything with that. And then I have sine squared theta. Well, I can do something with that. If I remember that sine squared theta plus cosine squared theta equals 1. So if I solve that for sine squared theta, I get 1 minus cosine squared theta. So I'll replace that right now. My denominator is 1 minus cosine squared theta. Then I have to go back to my algebra days, and again, I'm not going to change my left-hand side quite yet. But my algebra days tell me that my denominator is what we call a difference of squares. A difference of two squares. Right, and that formula was like a squared minus b squared, and then in parentheses a plus b, a minus b. All right, it's algebra 1, algebra 2 stuff. So we can change this to 1 plus cosine, 1 minus cosine. And you can check that if you want to by foiling. But if you check it, you get 1 minus cosine theta plus cosine theta minus cosine squared theta. These cancel out, and I'm left with exactly what I started with. So that's what we call a difference of two squares, difference of squares. Now the reason I did that, of course, is because now I have a really nice cancellation. So I have a cancellation of 1 minus cosine and 1 minus cosine. They're going to cancel out, leaving me with just 1 plus cosine in the denominator. And that's where I'm going to leave that for now. I'm going to start working on the left-hand side and see if I can't get the left-hand side to be that exact thing. Okay, so let's see. Secant is 1 over cosine. So I'll change both of those. And my denominator has 1 plus a fraction. Let's try to combine those. So I'll rewrite my numerator for a second. My denominator is 1 plus 1 over cosine theta. I want to get common denominator. So I'm going to change 1 to cosine theta over cosine theta. Right, that's just equal to 1. But I did it in that way so I can get common denominators. So now I can add cosine theta plus 1 in my denominator. Cosine theta plus 1 over cosine theta. My numerator hasn't changed. So I'm trying to get that to be 1 plus cosine theta. Okay, well, let's see. Let me give myself some more space here. Remember when I have compound fractions, right? 1 over cosine divided by this fraction. What I like to do is I like to keep it, after I've written it horizontally, I like to keep it, switch it to multiplication, and flip it over. Keep it, switch it, flip it. Let me bring this down again. I don't want to get lazy here. That reminds me what I need to get it equal to every time. So if I keep it, switch it, flip it, you can see that this and this are going to cancel out. One's on top, one's on bottom. So I'm left with 1 over cosine theta plus 1 equals 1 over 1 plus cosine theta. And I'll just commute these. Addition, you can just kind of mix around like that, no big deal, and I'm done. That was a tricky one because we had to change both sides. Normally you just change one side to be the other, but that one was pretty tricky. Let's do one more, and this will wrap up our trig identity series. And by the way, I have a lot more examples that I can do, and maybe in the future I'll make a more advanced, an even more advanced series of videos on identities, but I think this is a pretty good start. Alright, so what you're looking at here is we have some square roots and some fractions as exponents and stuff. Okay, so I think they both look kind of complicated, so maybe I'll just try to change this one. This one looks pretty crazy. So what I'll do is I'll change cosine to the 3rd power of x. I don't really know much about that, so maybe I'll try to split that up into cosine squared x times cosine to the 1st x. Because I do know something about cosine squared x. I can transform that pretty easily. What I'm also going to do is take sine of x underneath the square root and change that into, remember, square roots can change into fractions as exponents, 1 over 2. So I'll change that one too. I don't need those parentheses actually. So these are all multiplied together. And cosine squared x, we already know that that's equal to 1 minus sine squared x. Pythagorean identity right there. So I'll make that substitution now. And let's see, I have one term here, even though they're multiplied together, they're connected by multiplication. So that whole thing can get distributed into here. So when we distribute that, we get cosine x sine 1/2 x minus, and I'm going to do this one, minus sine, I'll write cosine first, cosine x sine squared x sine 1/2 x. Okay, so let's see. I'm starting to look at these exponents and realize that I need to simplify them. So what I might do is, if I change this exponent of 2 to something over 2, I can add it together with 1/2. Let me do that. Cosine x sine 1/2 x minus cosine x sine 4 over 2 x sine 1/2 x. So right there I just simply changed 2 to 4 over 2. I did that so I can get common denominators. 4 over 2, and I'm going to add that to 1 over 2. I'll rewrite everything else. Minus cosine x. 4 over 2 plus 1 over 2. Remember, these are multiplied together. The terms are multiplied together, so we're going to add the exponents. So I get 4 over 2 plus 1 over 2. That's 5 over 2 x. Okay, let's see. If I look at the top, look at the left-hand side. Let me bring that thing down. All right, so I have sine 1/2 x cosine x minus sine 5/2x cosine x. Let me bring that down. I should have been writing it all along, but I didn't. That's okay. Okay, so I've got my first term is sine 1/2 x cosine x. Same thing over here. They're just written in a different order. So maybe I'll write them in the correct order. My second term is minus this thing in a different order. That's pretty cool. I'm pretty much finished. So that was a pretty cool verification because it involved you having knowledge of exponential arithmetic, which again is like an Algebra 1 or Algebra 2 skill. So there you go. That wraps up my identity series. There are lots more that I can do, like I said, but I'll just stop right there for now, and I'll put these videos online for you to check out. But I hope you enjoyed this series, and I will see you in the next one.